So thank you so much. Really cool having me here. I will going to show you something about, because everyone is talking about AI, what AI can do, what ChatGPT can do, and I try to kill some myths around what is capable today in healthcare systems and what have already been done. So just quick hands up, quick exercise in the morning. Who has already used ChatGPT for business or private reasons? Hands up. Me as well, by the way. And this is, by the way, the best sparring partner I have in business. Before I go to a colleague, before I go to, I don't know, my manager, I ask first ChatGPT for a first idea. And when I introduced ChatGPT, I would love to talk about how OpenAI introduced ChatGPT in November 2022. And I would just read it out. ChatGPT is trained to follow an instruction and a prompt and provide a detailed response. Doesn't sound crazy, right? I think Google can do this as well. It's okay. Crazy. Let's have a look how ChatGPT, and I'll introduce ChatGPT for the first time. Oh, yes. Oh, for sure. Let me stay here. How OpenAI introduced ChatGPT 5 months later. I'll read it out again. ChatGPT exhibits humans' level performance on various professional and academic benchmarks. That sounds crazy, right? And this is already more than 1 year ago. So if we would now look on the very newest version, ChatGPT 4.0, this would be maybe even crazier. So this is what AI is capable of today, especially the development in 5 months. So we should think about how to apply this in healthcare as well. Why healthcare? Healthcare data is large and complex. ICD codes, so diagnosis codes, we have roughly 70,000 different ICD codes. Most of the patients, especially in oncology, are very complex, have much more than one ICD code, so multiple diseases, showing that just one information or two information is not enough. And this information and data load is really increasing. Secondly, I think at least I have already seen a few people here in the room with these smartwatches. So on an average lifetime of a patient, so from birth to death, we roughly generate 1 million gigabytes of data points. This can be MRI scans, this can be just some biomarkers from a lab or from an anamnese. This could also be from a smartwatch. And I think this information is even increasing. So this data load is heavy, and this data is already there. So instead of making new stuff and creating new data points, can we leverage these ones as well? To compare what means 1 million gigabytes, it's roughly 300 million books. So if we all together today start reading, I think we can't exceed 300 million books. So much data is already there from each of one in the end of the lifetime, and can we make something out of it instead of generating even more? And the last thing, when we think of, okay, what do we need to make a decision? There are studies showing that physicians roughly need 5 to 10 data points, especially in oncology, a bit more, in order to make a decision on treatment, on diagnosis, on follow-up decisions. And if the data is different than what they're expecting, we are talking about strangers, runners, repeaters, strangers. So runners are the easy patients. Repeaters are the crazy ones coming up more often, so I know them. Strangers, completely unknown because completely different mobility, different biomarkers, never seen that crazy situation before. And if we talk about these repeaters and strangers, studies show that with data, too much data and abbreviated data, this can go hand in hand with mortality and morbidity. So that means patient impact and patient health is impacted. So we need to think of how to leverage this large and complex data load in order to make a better patient outcome. So what can AI and algorithms do today? So there are various studies, and some of them is also what we can show from Roche as well already in a few customer areas. So the first thing is when we talk about AI and we talk about regulated AI, meaning as a medical device with clear sensitivity and specificity shown in studies, so really regulated AI models, we can show that these evidence-based algorithms create more confidence in decision-making for the physicians. There are studies ongoing and already showing that the confidence level of the physician is higher once they use regulated and really AI with this clear sensitivity and specificity regulated as medical device. Second thing is, obviously, wherever we can reduce potential errors by human, because this is natural, everyone knows this, a typo in an email, or if you use your calculator, you type something in, sometimes there happens that you have a typo. Whenever we can reduce it, we should reduce it. This is also what AI can bring. Next thing is, the first thing is workload reduction. We have a customer in Germany where we showed that in a very staff-shorted lab, we can reduce the workload by 80% because we just standardize processes with AI and algorithms. And the last thing, IVDR compliance is really specific to labs, which means wherever you can increase the quality of a process by automation and standardization, you should do this in order to reach a certain level of quality. Last thing, and this goes more than in the direction of costs and payer situation, which is also in the cost pressure situations in most of our healthcare systems really relevant. We can show that AI can reduce costs for diagnosis. This is right now a vitamin D study, but there are much more to come. But this is the first starting point I would say, that we can not only show operational effectiveness with AI, but also time to diagnosis and cost of diagnosis really enhanced. As well as, and this is something I would not like to forget, additional benefits for the system as well, higher adherence to guidelines, because it's just a decision support for the physician, as well as cost savings for payers, which is really relevant for the pressure in healthcare systems today. So what is AI already capable of? This is a study done to evaluate MRI images, doctor versus chatbot. And just hands up, I will show the two answers. This is the first answer, an extremely obvious breast cancer on MRI. This is the first answer, either from chatbot or doctor. And this is the other one. I won't read it out because I think I will make a mistake because I'm not a physician. So hands up, who thinks on the left-hand side is the answer of the doctor? Who thinks on the right-hand side is the answer of the doctor? So left-hand side is doctor, right-hand side is ChatGPT. This is crazy, right? So just from this image, on the right-hand side is what ChatGPT can see. This is really crazy, right? Another example where to show what AI is capable of today. So there were a study done with the top, I think, 50 questions patients have on social media. I don't know. My head hurts. What should I do? I have one leg less. What should I do? And that was, these questions were given to a cohort of physicians and to ChatGPT. On the left-hand side, you see the answers on a quality rating, meaning how good was the answer provided by a physician and provided by ChatGPT. And the quality was evaluated by another cohort of physicians, not knowing which answer was from a machine and which answer was from a physician. And if we just look on it, and I will just walk here. So this curve, the darker curve actually is the physician's curve, and the lighter curve is the chatbot curve. What you see on the left, from very poor to very good. So what you see where the chatbot and the physician have their peaks, meaning that the answers of the chatbot were, from a medical perspective, evaluated by very well-trained physicians, were better from a medical perspective. Then the second question was, okay, on an empathy side, so how empathic is a ChatGPT or a chatbot in general? You see again, the darker curve is the physician, the lighter curve is the chatbot. We go from not empathic to very empathic. And when you look on it, where the doctor or the physician has their peak and the chatbot, same on the, like on the left-hand side, right? More empathic, the chatbot is more empathic in giving the answer because he's trained on that than the physician. Physicians don't have time, they have staff restrictions, they have too much to do, so they just say obvious cancer on MRI like we have seen in the slide before. Whereas the large language model in ChatGPT, for example, is trained to be empathic, because they can generate it in, I don't know, some milliseconds. So why is this not existing today? So why is not every clinician and hospital in the world working with that? And I try to illustrate it here. This is how ChatGPT works, and all these big chatbots, they take different data sources in order to consume them, massage them, and tell the physician and the patient what is the best idea. They take images, this is what you see on top. Then they take clinical notes. Then they take time series. They take structured EHR data, so electronic health records. They take genome sequencing, if possible, as well as some other genetic information. The crazy thing is, this is not available structured. This is the big issue why we can't use it today. And nobody has time to fill out ChatGPT in routine usage every time. And the even better thing, besides unstructured data, there's no evidence. When I would type this in ChatGPT and I tell him my symptoms, and ChatGPT would give me an answer, ChatGPT says, but don't trust me, I'm not a physician, please contact your physician. This is the problem. So that means these ones are absolutely not regulated. Nobody knows what the accuracy is. There are some studies, but it's not regulated. There's no medical device. That means if there's something happens from a legal perspective, it falls back to the physician. Nobody takes responsibility for that. This is the reason why this sounds really crazy and really cool, but it's not there yet. What we as Roche have done then in order to overcome this is really, really crowded, this slide, I will start on the left, is a so-called one-stop shop for medical algorithms, which is called Navify Algorithm Suite. You can imagine it's like your app store on your smartphone. The reason why you use your smartphone is not because of the camera is so crazy, although you take already photos. The camera is not so crazy or the display is so crazy. You use it because this is obvious. You use it because you have all your apps you need on a day-to-day business or a day-to-day life in this app store. You have Instagram, you have your emails, you have your newspapers, then you have WhatsApp and whatever you need. You have everything in one place. Same analogy applies for the Navify Algorithm Suite. What you see on the left, we as Roche develop algorithms and AI models. And one day we learned as well that instead of competing with others, like your app store already does, why not bringing them on our app store? This is why you love your app store as well. You don't have just Samsung or Apple or Huawei or Xiaomi applications there. You have applications from third-party vendors all around the world. And only then it makes sense. What we're going to bring here then is this so-called, you see this cloud, it's an algorithm app store, meaning we bring CE, so medical device certificated algorithms with studies, like you know this from drugs or from biomarkers, normally in hospitals, in one place. And you see already there is a lung, there should be, I think it's a heart, a stomach, and a lung, and a kidney, meaning we develop algorithms and bring in third-party vendors from all around the world with solid algorithms, solid AI models, which are certificated as medical devices with studies, so that the physician can rely on these algorithms and know what to expect and what the failure or the area under the curve really is. How is it done? I'm really proud that we don't have any interface. I was in a congress last week presenting this product to a few customers, and they told me, show me, show me, show me. And I was so proud because I said, I don't have an interface, I can't show you. This is why you see just this, illustration here, because I recently learned from a CIO that in a big university clinic, most of the physicians have roughly 30 to 40 interfaces and windows to work in. So if we as Roche would then add another interface, I think the acceptance wouldn't be good. That means how these algorithms work, like a digital biomarker. You order it and you get it, like a normal parameter, for example, from a lab. Like a normal blood test, how you order it, you just get it back as a number, as a yes or no, as a black or white, whatever the algorithm gives out. This is so important. It's not needed that anyone types something in. We just take the structured data automatically, give it to the algorithm works in the cloud, and just send it automatically back. This is, I think, how AI and algorithms should work in the future. Oh. So just a few ideas what we do and where we do it. First thing is risk in colorectal cancer screening. The acceptance rate of colorectal cancer, so stool test or coloscopy, is quite low, unfortunately, because it's somehow uncomfortable. That's why we developed the so-called CDS system, clinical decision support. We see all our algorithms are one information point in the entire patient view. We developed this as a personal recommendation for colorectal screening. It's a machine learning model, and the cool thing is, and this is where I'm really proud of, we just use existing blood parameters, so information which are already there and which are structured there. We test for validation for desirability and feasibility. Next one, because I think the time is already nearly over. Patient-based real-time quality is really about efficiency gainings in the lab. So in order to find where are reagents not good or machines not good working, and again, we just take data from patients which are already there. Then something in pathology, where we try to kill blurriness on slides, on digital slides in the pathology, in order to kill some artifacts and really rebuild and restructure the image. Clinical evidence monitor, really in making a decision for a patient in oncology in tumor boards, in order to leverage unstructured data, make them available in a structured format, and show where's evidence and studies existing already today for this patient. Last but not least, the so-called liver cancer algorithm, where we have just a mathematical regression, so not too fancy, but it's not needed because the model is not needed. It's just needed where the medical need is. We just use existing immunology parameters. To cut a long story short, we work from screening with algorithms to laboratory, to pathology, to treatment decision-making, to surveillance, so along the entire patient journey. Last thing, in a summary, AI today in ChatGPT. So I think everyone used it already, or nearly everyone, 80% in the room. And it changed our understanding sustainably how we think about AI. And this will come, truly. Good and bad on the same side, it's not yet there in daily life, especially in healthcare, because of the unstructured and non-regulated thing I already mentioned. Nevertheless, how should ChatGPT work in medicine, especially oncology in the future? It should be evaluated as clinical decision support. The decision in the end is always in the hand of the physician. It's just a one information spot, a digital biomarker, digital parameter for the physician. It must be explainable, and this is why ChatGPT still is not there yet, because with all these so-called hidden layers to explain how ChatGPT comes to a certain decision, it's just not explainable to a physician. And with that, the acceptance of the user, of the physician, would just really decrease. And the last thing, it should be certificated as a medical device in a regulated environment, because otherwise it's a so-called, how I always call it, garage algorithm. You can't just use it. Thank you so much.